All right, we're going to talk about section 8.3, which is talking about equations of lines and linear models. We're going to be talking about point-slope form of a line, slope-intercept form of a line. We're going to do a quick summary of all the different forms, so this is a good slide to make sure you have on the day of the test. And we're going to talk about how to create linear models. So what we're talking about here are just different formats for equations of lines. You know, not every time, you're not always going to get things in a standard form. Remember that ax plus by equals c. Things are not always going to be in that standard form. Sometimes things are going to be solved in terms of y, and sometimes they're going to give you other information and ask you to figure out the equations. So the first one we're looking at is what we call point-slope form. If you'll notice the different parts here, m is your slope, and y1 and x1 are 1 point that are given to you. So you'll be given 1 point in the form x1, comma y1, and you'll use that point to figure out this equation. So here we have an example. The slope is 1/3, and the point is -3, 2. So here's x1 and here's y1. So using our formulas, we're going to say y minus 2 equals the slope, oops, sorry, that's 3, the slope, parentheses, x minus -3. So this is going to be y minus 2 equals 1/3 x plus 3. So then you're going to continue to solve that. Now the biggest thing I told you about is remember that in standard form, because they're asking you to put this in standard form, and standard form is ax plus by equals c, where a and b are integers. So we do not want this fraction that we have here. So what we're going to do to get rid of the fraction is we're going to multiply both sides of the problem by 3, which is that denominator. And when we multiply by 3 over here, we get 3y minus 6 equals, the 3's over here cancel out, which is nice, and you're left with x plus 3. So now just manipulate the problem. We want to get the x's and y's together. So we're going to subtract x from both sides. So you get 3y minus x equals, we're going to add 6 to both sides. So you get 9. Okay, and I'm going to be picky again and say x has to be first. So if I reverse this, I get -x plus 3y equals 9. And then some people will be even pickier. I'm not sure exactly how my math lab works, so you'll have to try it both ways. Some of them will be even pickier and say that this can't be negative. So they will take this whole problem and multiply everything by -1, and they end up with x minus 3y equals -9. Now my personal opinion is that this is an acceptable answer, or -x plus 3y equals 9 is an acceptable answer. But again, I'm not sure how my math lab will respond to this, so I would recommend that maybe you try it one way, and if it marks it wrong, you can just put in the other option when you re-enter your problem. So our second example, we want to find the equation given 2 points. Now the problem here is that in order to do our point-slope form, we have to know the slope. So we're going to take these 2 points and we're going to find the slope of those 2 points. So we're going to put it into our formula. We're going to do 3 minus 1 over -1 minus 2. So we end up with 2 over -3, and that's our slope. So now, pick either point that you want. It does not matter whether you pick the first point or the second point, and we're going to put it into point-slope form. So we're going to go into our formula, and we're going to say y minus y1 equals slope x minus x1. and we're going to pick either point that we want. And I think the example is using the point 2, negative, or 2, 1. So we're going to plug that in there. So 2 minus 1 equals the slope, negative 2/3, x minus 2. Again, we don't like having that fraction, so we're going to multiply both sides by 3. We don't care about the negative 2. We're going to multiply both sides by 3 to cancel out the fraction, and you end up with 3y minus 3 equals, 3's cancel out, negative 2, x minus 2. So you get 3y minus 3 equals negative 2x plus 4. We're going to reduce this down, so we're going to get 3y plus 2x equals seven. And so then in standard form, we end up with 2x plus 3y equals 7. All right, our next problem is in slope-intercept form. In slope-intercept form, what we're going to do here is we want the problem to be in the form y equals mx plus b. So this time y is by itself and b is on the opposite side. B is what we call the y-intercept. Remember we talked about y-intercept, that's where we cross the y-axis. And m is your slope, just like before. So we're going to look at problems that are in slope-intercept form. So if we look at a problem like this, the 3/2 is our m because it's the number with x, and the negative 2 is our b, it's our y-intercept. So our slope equals 3/2, and the y-intercept equals 0, negative 2. So now if it tells me to graph this, we're going to graph this just like we did the previous problem with the point and the slope. And what you're going to do is you're going to graph the y-intercept. So we're going to graph 0, negative 2, the y-intercept. The slope is 3 over 2. So this is our rise. This is our run. So we're going to rise 3 points. We're going to run 2 points. And there's our new point. So when I connect those 2 points together, I have my line graphed. If I chose to, I could go from here, the green dot, and I could do rise over run again. So I could go up 3, and I could go over 2 again, and you'll notice that right there is my next green dot. That line's going right through those green dots. So in a summary, these are all of our different problems. So we have ax plus by equals c. That's called standard form. And in standard form, a and b are integers. And preferably a is positive. Okay? With the vertical line, you have the form x equals a. Vertical line, slope is undefined. Horizontal line, y equals b, and slope is 0. Slope-intercept form is in the form y equals mx plus b. Y is by itself. M and b could be decimals or fractions, so don't be alarmed by that. So m and b are real numbers. M is the slope. B is the y-intercept. B is the y-intercept. And so B should be in the form 0b. And in the last one, point slope form, again, m is the slope. And the x1, y1 is one of the points that you're given. So occasionally with this, you will be given 2 points and you'll have to just pick one to work with. So when we talk about linear models, what we're trying to do is figure out, given real information, what kind of line we can create from this and be able to use that line to create futuristic or future options as to what our future outcomes would be. So here we have estimates for medical costs, and this is in billions of dollars. So in the year 2000, they estimated the medical costs are 225 billion. In the year 2001, it was 243 billion, and it goes up on the chart to the year 2004, where it's 297 billion, excuse me. So what they want you to do is create an equation, assuming that this is a linear cost, which they're saying it is. That isn't always true. And then they want you to use that equation to figure out how much it would cost in 2010. Now, what they're going to do to make it a little bit simpler to deal with is they're going to assume that year 2000 is 0, this is 1, this is 2, this is 3, and this is 4. So the year 2010, you would be using the value of 10. We're going to take each of these values in the chart and create an ordered pair with it. So 0, 225, 1, 243, 2, 261, 3, 279, and 4, 297. And so that's what we're talking about here. We're saying x equals 0 corresponds to the year 2000. X equals 1 corresponds to the year 2001. And that just makes it simpler to work with. It doesn't have to be done that way, but it just makes things a lot easier. And then we took each of those and we created our ordered pairs out of this information. Okay, so now we need to figure out the slope so that we can go through and do point slope form. So in order to do that, I've got to take two of the points, and it really doesn't matter which 2 points that you use. Occasionally they'll tell you which 2 points to use, but it's a good idea to use the numbers a little bit spread out. So you'll notice that the 2 points that they picked are the 0, 225 and the 3, 279. So they didn't pick 2 right next to each other. You could have picked the 4. It really doesn't make any difference. So we're going to use our slope formula. This is x1, y1, x2, y2. We're going to plug it into our formula, and we end up with a slope of 18. And now using one of those 2 points, and what they recommended doing is that we already know our y-intercept. Here's our y-intercept right here. So why not, that's our b value, so why not go with our y equals mx plus b formula. I know what m is 18, b is 225, so now I can plug that in to this formula. Now if I did not have the y-intercept, then I would have to take my point slope form and I would have to use one of those 2 points, either the 0, 225 or the 3, 279, and I'd have to plug it into this. And I should get an answer either way, very, very close to this one that I've got here. So now this is my model. This is what they refer to as the model. In other words, this is my equation. And so I can use this equation to estimate any value that I choose. And I want to know how much is it going to cost in the year 2010. And we already talked about that. That means that x is equal to 10. So we're going to substitute that value of 10 into this equation, and we're going to get 18 times 10 plus the 225 is 405. So according to the model that we found, that in the year 2010, medical costs will be approximately $405 billion. So if you wanted to figure out how much it was going to cost in 2013 or 2014, you could substitute that value in here for this, and you could figure out the estimated medical cost. Now that is an estimation, it is a model, but it doesn't necessarily mean that that's the way it's going to be. All right, I hope this helps. Keep in touch with me. Let me know if you're having any problems, and have a great week.